Welcome everybody to our topic 8 just-in-time session. We're so glad you're here with us. Michelle has dropped the Pear Deck in the link, so you can jump into that and follow along with us. Just a note, this session is being recorded, and we will provide the resources of the recording and the slide decks afterwards. Okay, so we are going to start with our land acknowledgement. And for our land acknowledgement today, we're going to read an excerpt from Deirdre Lee's poem. Now, Deirdre Lee is a poet, performer, a maker of art, food, medicines, and magic who lives in the traditional and unceded territory of the Micmac. We're going to read this poem out loud because it's meant to be read out loud. It is a 9-step poem, which we have taken just the first 4 out. Little excerpt for us. Step 1. Read this poem out loud, ideally outside in the sun, so the trees and the wind can listen in. If this makes you roll your eyes, stop, go away, have a nap, try again. Step 2. Learn what unceded means. Understand that this is just the beginning. Step 3. Be present. With feelings of being uncomfortable or embarrassed, you could probably use the practice, realizing these feelings are not life-threatening. Step 4, locate yourself, specifically, geographically, time for Q&A, time to know, time to say, whose traditional territory do you live and breathe and work and love upon? Who is here for thousands of years before you? We would like to begin by acknowledging that the land on which we gather today is the land traditionally used by the Haudenosaunee, Anishinaabe, and Neutral peoples. We also acknowledge the encouraging presence and deep traditional knowledge, laws, and philosophies of the Indigenous people with whom we share this land today. Okay, so today's agenda is we're going to look at pacing. We're going to talk about how do we fit it all in. We started talking to this topic, this idea last time with topic 7. We're going to continue. We're going to look at topic 8, specifically some points from the curriculum, LRP site, and we're going to look at measurement across the grades. We're going to also take a big chunk of time, hopefully, to do proportional reasoning and measurement, spatial reasoning and measurement, and algebraic reasoning and measurement. And there's going to be some activities here that are going to engage you. And then we're going to look at Q&A afterwards. Okay, so this is a moment where we'd like to take a moment and just ask you, what topic are you currently teaching in math? We've been doing this for the last few sessions, and it's just provides us with a little bit of data for us to be responsive as we move forward. So if we could take a minute and just pop in the appropriate topic that you are in, they'll give us an idea.
So thank you to those of you entering in the chat. You can also enter it right in the Pear Deck if you use the Pear Deck link that I shared. It's a survey, so there are 4 choices. I think 4, maybe 5. I'm not sure of the choices.
Yes, there are 4.
Why is there not a chat for spatial sense? Like maybe you are starting measurement this week.
Oh, yeah, that could. We haven't adjusted that accordingly. So
and that makes sense because we have we're in the midst of and finishing up reporting, so that actually makes sense.
So what I will say is, well, I'll maybe pop that in the chat if you're in that, then we'll know if you're on starting topic 8.
I mean, that should line up with your timeline, right? Like 2 weeks, so first week of February, I should be starting spatial sense if I'm trucking along. It's good.
Absolutely. Okay, I'm going to go ahead and jump on to the next slide. Hopefully that gave you enough time to pop your response in. So let's talk about pacing for a moment. We recognize that this is a lot for us to get through these topics with the number of limitations we have. And we've provided a document, and we've talked about this in our last session, to give you some strategies for efficiencies in instruction. And this document is linked on this slide. We did take a look at that document in more detail. Today, we're just going to speak to the main points of the document that's presented on this slide. And then we'll give you like a heads up about what's coming up next week that's going to give you further support. So first point, plan with the overall expectations in mind. So we're going to do our best not to get lost in the specific expectations, but to keep the big picture in mind, because we know some of those overall expectations is something that are in these topics that we come back to. Number two, we want to note some topics that are revisited across the year, which connects to what I just said. So you don't have all your students at the level, the point of understanding or competency that you want them in a specific topic. Doesn't mean that you can't move on. So they will have other opportunities to grasp these concepts and see them maybe in different angles that'll give them an aha moment or a better understanding. So sometimes we tend to stay too long on a topic if we find that not everyone is exactly where we want it to be. So there is opportunities for revisiting topics across the year. We want to use recursive strategies to chunk some topics into smaller blocks. So when we're thinking about some of those recursive strategies, we think about number talks, possible ways to integrate some other topics into what we're doing right now so that we can have smaller chunks or smaller opportunities to revisit. One of the things I wanted to mention is also, these expectations are year-end expectations. So a lot of times when we look at a topic, we think because the expectation cluster is listed, that is actually a topic end expectation. So we keep pushing and not realizing that, hey, these topics and these concepts are actually revisited in other topics later in the year. So those are year-end expectations. And of course, we want to use assessment data to drive instruction decisions. So if we have students that have achieved competency because of, maybe they come in and we do a diagnostic and we see that, a lot of students are already comfortable with this idea in this topic. We don't want to spend too much time on that because we want to be responsive to what our students need so we can push ahead. So that is a way of saving time as well. So this is kind of a big overview. Please feel free to check out that document and read it a little bit closely throughout the week. There will be more information about this coming next week in some lunch and learn sessions that will focus on supporting you as you implement this. We realize this is a need for a lot of people. So as always, we also do ask that you reach out to your school consultant to help you support in some of these planning and implementing of these strategies. All right, so that's kind of pacing, speaking to that before we get into the topic. And now we're going to get into the long-range plan topic for topic 8, which is we're looking at measurement across junior. So when we look at measurement, it breaks down into two kind of categories under E2. One idea is we focus on students working with metric systems, estimating, measuring, and comparing and converting. And then in that, we look at specifically, they're looking at the types of unit changes across the grades. So from 4, 5, and 6, they're looking at various conversions. And we'll look at that in more detail in a couple of slides. But it's understanding the metric system and how it can compare to other measurements in the metric system, especially looking at not just length, but mass, capacity, and area. And then the other half of our topic is dealing with the concept of area. So we're looking at, types of figures and area relationships and how they change across grade 4, 5, 6, and the various. We're going to look at this in some of that spatial sense and different math ideas, but the various shapes and how area is determined in those shapes and how they relate to one another is a kind of overview of what we see across 4, 5, 6. So this is a continuum of measurement concepts for across primary and junior. It's kind of a visual way of representing how the curriculum is set out. So we're just going to take a moment, some time here to go through some of these, because I know there's quite a lot happening in this visual, but if we can speak to it, I think it'll be a good reference point for us to actually come back to understand where our students are at and where they're going to go. So you can see that in primary, the main focus is draw, measure, and explain. You see those two areas, metric and area, outlined there in grade 1, 2, and 3. So when we're looking at metric in grade 1, they're using measuring with non-standard. And then in grade 2, already in primary, they're dealing with length measurements going from centimeters to meters in very concrete ways and converting those two and getting relationships between those two. And then grade 3, we expand from still in the linear realm, measuring length, and we go from millimeters, centimeters, meters, and kilometers. We've added that full, almost full gamut of metric length measurements. In area, you notice that in grade 1 and 2, there's not much happening. And then in grade 3, they're measuring area with non-standard units. They're estimating using square centimeters and square meters. So they're conceptualizing what a square meter is. And I remember doing that a number of times in my class. What does that size look like? And a square centimeter is. So they're estimating with that. And when we get into junior, we're going to go back up to that metric row. When we get into junior, we can see that they're dealing with length, mass, and capacity. So they're adding to what was happening in grade 3, the idea of length, conversions in metric, and they're adding that relationship between units into the capacity and mass. So we have grams to kilograms, and then we have milliliters to liters. You see that those two relationships are similar, right? 1,000, that proportions of thousands is in there between capacity and mass. And then in grade 5, we move on to adding relationships in area, units. Big note here is there is no conversions for area. So we do convert, grade 5 does convert larger metric units into smaller metric units. So they're doing full conversion calculations at this point. You'll notice in grade 4, they're dealing with relationships, but they're not fully converting. But there are no area conversions because that square units get complicated when you're converting between, say, square meters and square kilometers. It's a much more exponential relationship. So there is no area conversion in grade 4, in grade 5, or 6. You'll note that's something that happens in grade 7. In grade 6, really they're building on everything, bringing everything forward. They're converting smaller metric units and into larger, and vice versa. They're full. It's kind of everything's open for them to work with metric. Down in the area realm, you can see that grade 4, we're dealing with the rectangle area formula. We're dealing with the relationship of what happens physically to determine the area of a rectangle and coming up with that relationship to formula, which Michelle is going to speak a bit more about later as well. So that same idea is built upon in grade 5 when we're dealing with triangle and parallelogram area formula. These, if you've taught 5, 6 for a while, these used to be a grade 6 expectation. They've been pulled back down to grade 5. And we're dealing with that area perimeter relationship as well. So problem solving around area perimeter relationships. And then in grade 6, we are getting into the decomposing and composing of different shapes to determine area. And specifically, we're actually going to be dealing with trapezoids, kites, and rhombuses, determining those areas. A note here, there is some good things in the teacher supports in the curriculum, digital curriculum document that will actually be kind of referred to later on in the presentation when Michelle's taking us through an activity as well. And surface area, which has always been a concept in grade 6, continues to be there as well. So that's kind of like a lot at you, but hopefully that now that we've spoken to this visual, you can go back and look at it and kind of be able to reference where students are coming from, building towards. I'm going to pause there and see if there's any questions potentially about what we've just talked about.
There was just a bit of a question about some of the changes, and I think you got at that, Hebron, when you spoke to the grade 5-6 and how some of the shapes have come down from higher grades. And then just one other thing to note is volume is no longer in the junior curriculum. So volume is now in grade 7.
And it's the mass and capacity, is that also been, how is that related to what they would have done last year in grade 3 or taken out of grade 3? Like, what would my students have learned about mass and capacity if I teach grade 4 this year, last year in grade 3? I mean, last year's a joke, but you know, I mean, half of last year is totally missing, and I have to acknowledge that. But will they have learned about kilograms and liters, and was that part of the old curriculum, or anyways, or is that no longer part of the new curriculum?
That's a good question. So it isn't in the new curriculum. They're strictly dealing with length measurements in the metric portion. I think it's always good to just, even if they would have covered something to do with mass and capacity in grade 3 prior to, which I'm not familiar with, so I'll have to double check. I think it's a good idea to go back and start. A lot of these relational, the way the curriculum puts it is they're not actually just, in grade 4, they're not actually converting, they're not dealing with problems where you convert, they're discussing and working with the relationship between mass of grams and kilograms, milliliters and liters. So I think it's a great place to start and build up from there, even if they've done it before. And I'm sure they've had some exposure to it. Michelle, do you know?
I think it was, and again, I'm not certain. I'd have to go back and look at the previous curriculum. But just as you were speaking, Hebron, it makes me think about connection to number sense, where we're just looking at quantity. So when we're asking students in grade 4 to be thinking about grams and kilograms, it's more the how muchness and the relative size. As Hebron said, it's not about converting.
Oh, you're muted.
Yeah, a millionth time today. The other thing is that the idea of like how much does a gram weigh and a kilogram weigh, and that we can have that maybe idea in our muscles and our heads about what is 1 kilogram and what would be realistic. That's been I've only done it for 2 days now, but that was kind of a big aha question for my students. Oh, like, my running shoes aren't going to weigh 9 kilograms. No. Anyways, so that's good. That's
yeah.
Good.
Those are fantastic ways of conceptualizing those benchmarks in their experience, right? So, yeah.
Especially when we don't have any access to weights. And that's in the math up curriculum, it's been tricky. Sorry, I'm going to let you get back on task in a second, but it's been tricky to figure out how to do mass and capacity without the hands-on tools that the school provides. They don't have weights. So how can I compare? Is this 1 kilogram heavier than that? Like, what would a kilogram weigh unless I have them? And I've had my students go find something that weighs 1 kilogram in their house and find a box of salts. So anyways, that's been good.
Right. That's what I was going to say, is having to go find. And I think that's a great idea. A bit of a scavenger hunt. See what you can find that has these units listed on it, and then hold them in 2 hands. And yeah.
Okay,
That's great. And connecting to those experiences, right? Mm-hmm. If you know the average sneaker, like you said, is like, I don't know, 300 grams or whatever, then it's like, oh, that's what 300 grams is. Then I'd have a comparison to something I've experienced. It's still a challenge, but it might be a bridge for sure. Okay, thank you for those questions. That's fantastic. And now I'm gonna hand it over to Michelle, and she's gonna walk us through some of concepts around those proportional, spatial, and algebraic reasons.
Okay, thank you, Hebron. So measurement itself is important. There are a lot of things within measurement that we want students to address and understand, especially the kinds of things that Megan was just talking about. When we're looking at this unit, it's also a really good opportunity to reinforce the important mathematical reasoning that we want students to be doing. So for example, proportional reasoning. And you'll see on the right that there are 3 paying attention to documents that are linked. And each of these has connections to measurement as well as the other strands. Our focus is measurement. But in proportional reasoning, if you think about just measuring linear relationships and the number lines, partitioning is proportional reasoning. Understanding that the 10 centimeters is this makes up a decimeter, and that there's 100 centimeters in a meter, which again is tricky when students don't have meter sticks at home. And the relationships between those metric units are proportional. They're all multiples of 10. Similarly, with spatial reasoning, paying attention to those intervals or spaces when they're measuring, choosing an appropriate unit of measure, and then thinking spatially about the relationships visually with rectangles, parallelograms, and triangles. And we do that through composing and decomposing. And we'll spend some time doing that today. And finally, making connections to algebraic reasoning. So anytime students are generalizing, they're using algebraic reasoning, seeing relationships between dimensions, perimeter, and area of rectangles, and then developing and using those area formulas in the junior grades is all algebraic reasoning. Okay, next slide. So we're going to get you actively engaged now in some proportional reasoning with a measurement task. The task is here. A rectangle and a parallelogram have the same base length. The parallelogram is twice as tall. If you know the area of the rectangle, how might you figure out the area of the parallelogram? And we want you to do this thinking about proportionality and exploring using Mathagon. So this is a polypad. And again, it's clickable on in your Pear Deck. So we want you to explore visually by manipulating. And then once you have something that helps you to see how you might figure out the area of the parallelogram, if you know the area of the rectangle and they have the same base, we're going to ask you to take a screenshot and put that into the Jamboard. Okay, at this point, I'm going to invite you to come back into the Google Meet. And Hebron, I'm going to ask you if you can project the Jamboard, please.
Mm-hmm.
So looking at some of the designs that have been created, what are some of your wonderings, noticings about what you see there? And I'm just going to ask you to unmute and share your thinking. So what are you noticing? What are you wondering?
The one I relate to the one that's like really small in the middle, like the 2 rectangles and the 4 parallelograms. I don't know if you were watching, but I kept putting mine on and deleting it and putting a new one on. That was me. Because the parallelogram in the polypad was a different size than the rectangle, and it was driving me like crazy. So I tried to draw my own parallelogram, but then my lines weren't parallel. So then I put that like weird circle thing and wrote, these are the same.
And that one's mine in the middle there, and I was having the same problem because they're not the same size. So then I just went with 4.
Okay, so I want to draw our attention to the one in the upper right, where the person has added the grid behind. So the grid behind on the Polypad app is really helpful. And as you all have noticed, they don't have the same height, which can cause us a problem. So if we're trying to say they have the same base but twice the height, how do we get twice the height? And then I want to draw your attention to the one that has the red. So we get kind of stuck when we look at some tools and we say, okay, there's a rectangle, there's a trapezoid, or sorry, a parallelogram. But there's also red parallelograms that you could also use. So you can note that the rectangle and 2 of the red parallelograms are the same height. And so if I double the height of the parallelogram, what does that tell me about the area? So that's where I like the one here that it says the same, where we're cutting off a bit, except that that shows a parallelogram and rectangles that have the same height. And the parallelogram is twice as tall. They have the same base. The parallelogram is twice as tall. So our whole purpose here was to get you thinking proportionally and not let the tool detract you from that. So yes, it was frustrating, and that's why there's other tools or other shapes in there to explore. And we were intentional with this because Hebron and I did the same thing. We're like, the blue's not quite right. And we're like, it's just a little bit off. And we actually wanted you to experience that same frustration because it reinforces for us the proportionality and how important that is. That if we're going to have students explore, we need to be giving them opportunities to think about proportionality and not simply something that's twice as tall. Like that isn't quite twice as tall. So with most of these blue ones, it's just a little bit off. Okay, any questions about that task before we leave it? Our whole purpose was to get you thinking proportionally, and we did that, albeit through your frustration, but that was okay for us. Okay, so Hebron, if we can go back to the Pear Deck, please, and on to the next slide. So we talked about that proportional reasoning, and now we're going to get you to do some spatial reasoning. We're going to use a different interactive strategy, which is the waterfall. So some of you who joined us last time will know how the waterfall works, but I will explain it. The way waterfall works is you're going to, first of all, predict which polygon has the greatest area, either the 1 or the infinity symbol. It's not a pair of glasses, Hebron. It is an infinity symbol. And so, and what you're going to do is you're going to, in a moment, you're going to put it in the chat, but you're not going to press send or enter. You're just going to type in either the word 1 or the word infinity. Then I'm going to do a countdown, and I'm going to count down and say waterfall. And then when I say that, that's when you'll press return or send. And we will get a waterfall of answers. Oh, that's awesome, Sarah. I'm glad you used it today. And hopefully you enjoy it as much as the kids. Okay, so type in which polygon do you think has the greatest area. Type in your 1 or your infinity. And I will count down 3, 2, 1, waterfall. Oh, and we have a variety of answers. I love it. So you can probably predict the next slide then. Hebron, next slide. You get a chance to explore. So remember, our focus here is on spatial reasoning. Which polygon has the greatest area? You now need to verify your answer. So you're going to use some composing and decomposing. You're going to click on the link in the Pear Deck that says Shared Google Slide Deck, which is going to take you to a shared Google Slide Deck. You're going to choose a slide that nobody else has chosen, put your name on it, and then you're going to move things around. So decompose and recompose to see if you can verify which of these 2 polygons has the greatest area. And I know you haven't all finished, but I am going to invite you all to stay in the slide deck, but I'm going to ask you all to jump into Caitlin's slide. So slide 15. So if everybody can go to slide 15. And then Caitlin, I'm going to ask you please to unmute and tell us your thinking. What are you trying to do here?
Personally, it just looked too confusing as the shape 1. So I figured if I could package that into a better looking thing, then I could start rearranging from there. And then I took the infinity, started changing them colors, and then starting to see what would fit together as a puzzle, and then try to make that match up.
Okay, so Caitlin has used an array of rectangles, so a shape that she knows, a familiar shape, to try to do what lots of you were doing, which is overlay. And then I'm going to ask you all now to jump to slide 3.
I'm thinking that better not be my slide because I had no idea what I was doing. I just keep thinking about how math and growth mindset are so closely tied together because I started and I stopped and I was like, I don't know. Like I spent a lot of time counting out how many little rectangles there were. And then I tried to do some measuring of like, okay, well, like is one, well, I think maybe one of these is the same as one of, like one of these is one of the same as one of those. So I think they are. That looks like about half, but I think, yeah, that's about half. So I don't know.
Okay, so Megan, you're in slide 4 and you're manipulating stuff. Can you go back to slide 3 and show us what you're doing there? So
It's the same colors. It's not your fault.
no, I think she duplicated her slide.
Oh, okay.
My face is bright red.
No, this is awesome. So no, please tell us some more about, like, you're about to compare one of the pink rectangles to one of your yellow rectangles, one of your skinnier rectangles to one of your fatter rectangles.
Well, my friend in slide 3, our slide decks look almost identical, right? Like you look at the two of them, they're like the same thing.
No, they are the same. I think you just duplicated it. It's
How
all
did
you.
How did I do that? I don't know.
I'm not sure.
Okay. You were talking about me. I'm not sure how it got duplicated. Okay. Yes. Here we go. The this here, I can tell when I line them up there. See how that little blue dot is the same? It's about halfway to that dot. I don't know. It's about, kind of looks like they could be the same.
Right.
So,
Okay. So Megan, our goal was not to embarrass you. I actually am.
I thought I was talking about I thought I was talking about my slide when you wanted somebody else's slide. That's what I thought.
No.
Okay.
No. It's totally good. You what I like what you've done, because you're again looking for familiar shapes, and as you were manipulating it, I was watching, and you're trying to say, okay, how many rectangles? They're going to sort of like almost cancel each other out, so I can see these are the same, and now I'm going to see how do these pink ones compare to these ones, and can they, you know, I might be using words you weren't thinking that will cancel each other out.
That one cancels that one out.
Right, and then to see what's left. Yes.
I think maybe 2. Is that like about 2? Yeah. Look at how those are like those are the same.
Yeah.
Right. Okay.
Yeah.
So this is exactly the kind of spatial thinking that we wanted you to be exploring here. Even though we're still thinking about measurement and area, it's important that students understand that if I rotate a shape, it still has the same area. If I decompose and recompose, it still has the same area. The area stays consistent. And so through this task, you get an opportunity to decompose, recompose, do a lot of thinking about spatial sense, and also reinforce your understanding of area, which was our goal. So what did we land on? Which of the 1 or the infinity has the greatest area? Who knows? Who was able to solve?
I think they looked like they were equal. They were.
Yeah.
I felt that I was getting close to making those shapes equal. I was just down to the little triangles, seeing if I could make that into the big triangle.
Okay, so most of us are thinking that they're probably equal. And again, that was intentional. 1 is slightly more, and I'm not going to tell you because you have that slide open and you can keep exploring if you like, or you can task your students with it and then they can prove to you which one is greater. We're going to go on to the next slide, Hebron. Okay, the final area that we want to reinforce within our measurement topic is algebraic reasoning. So anytime students generalize or solve using equations, they are using algebraic reasoning. In grade 4, we want students to have opportunities to explore a variety of arrays in a rectangle and make that connection between the rows and the columns to generalize to come up with that formula. And notice when we're talking about the area of a rectangle, we're not just using length times width. Traditionally, we use length times width, and there's nothing wrong with it. But if we also refer to those dimensions as the base and height of the rectangle, it's going to give students some of that vocabulary that's going to support them when they move into different shapes. So in grade 5, in that second row, we can see that we're trying to look at the relationships between a parallelogram and a rectangle. So on the far left, you can see we've cut off a little bit of the parallelogram in blue. We move it to the right, it makes a rectangle. So we can see, oh, it's the same, the base and height. And by, again, having students explore a bunch of different parallelograms, they can see that it's actually the same as a rectangle with the same height and the same base. And then by exploring halves of parallelograms, we can see any triangle is going to be exactly half of any parallelogram. And we can generalize to get that formula. On the far right, before I get to the grade 6, you can see that in grade 4, I've intentionally provided the area and left the height as the unknown. We don't want students to think that solving equations is always to get the answer on the right-hand side. So we want to make sure that we give students opportunities to explore being given the area or the height or the base and having to solve. And that is new to grade 4. Solving equations didn't used to come into the curriculum until much later. And so it's simple equations, and it's by guessing and checking and making sense of it. In the grade 5, that's a modification of the problem that you worked on in Mathagon. So the areas of a parallelogram and triangle are both the same, 24 centimeters squared. If they both have a height of 4 centimeters, what is the base of each? And so it's reinforcing those relationships between a parallelogram and a triangle. When you look at the grade 6, big difference for grade 6, is that they don't have to generalize any new formulas. They have been exposed, or will have been exposed a couple of years down the road, to area of a rectangle, area of a parallelogram, area of a triangle. That's all they need to be able to find the area of any other polygon, given the proper dimensions. So for grade 6 this year, yes, you're going to have to make sure that they explore parallelograms and triangles because they haven't done that. And then when it comes to moving forward and still within this year, these are 3 different ways, and this comes right from the curriculum. Hebron was mentioning that the teacher supports within the measurement strand in the digital curriculum are really valuable. These 3 diagrams come right from the curriculum, and it shows 3 different ways of thinking about and decomposing and recomposing a trapezoid to be able to find the area. And so there are 3 different formulae, none of which is the right one. They're all valid ways of finding the area of a trapezoid. And there's actually a 4th way as well in the curriculum. And then if you look at the problem, it's nice to make give students an opportunity to do some thinking on their own. So what would realistic dimensions be for a skate park that looked like this? And then figure out the number of square meters of plywood. So now we're taking that application to surface area, because in grade 6, they extend their thinking about area to surface area of 3-dimensional figures. So those are some problems that students would be solving and needing to use their algebraic reasoning to get there. Okay, Hebron, next slide. So we focused on those 3, proportional, spatial, and algebraic reasoning as the types of reasoning we want to emphasize within our measurement unit. Some other tools to support your students as they're engaging with the measurement topic are color tiles, especially in grade 4, because we're looking at those rectangular arrays, pattern blocks and the relationships among the pattern blocks, the polygon pieces, when and if we're back to face when you're addressing this topic, and you have those in your classroom and you can, the whole health and safety thing, those are a useful tool, especially in grade 6, looking at the faces of 3D figures. And the link to the polygon pieces is the same link that we use today, the Mathagon website. And then grid paper, there's not a nice online version of grid paper. You just put it as a background in a slide if you want students to be able to use grid paper. So you can take a picture off if you search for an image in Google and you put it as a background on a slide, then students can't move it around accidentally, and they can move shapes around on that grid. So those are just, that's a resource slide for you to access those virtual tools. And yes, Jamboard works too for the grid background. So that brings our session to a close. Our timing is pretty good. We have about 8 more minutes, and we are open now to any other questions you might have about the measurement topic. And also, if you've gotten what you've come for, please feel free to head out. But we are going to take your questions. And actually, Hebron, do we want to go ahead to the next slide just so we give them a heads up? So this is a Pear Deck slide. So we would appreciate if there's something you're taking away from today's session or something you're still feeling unsure about, you can share that with us. There will be a next just-in-time PD session. Right now, we're looking at a couple of different weeks, but we're trying to use data from both primary and junior teachers about where they are currently. And then just a reminder that Hebron mentioned that next week there will be lunch and learns that will focus on the long-range plans and looking at the topics still to be addressed and how we might be able to address those topics. Because although some of you said you're right on track, we know that across the system, for various reasons, teachers aren't all in the same place. And so we're going to be addressing that through some lunch and learn sessions next week. So we're going to leave the slide here so you can add your thinking about something you're taking away or something you're still unsure about. But we also want you to ask questions if you have them, because that's what we're here for, is to answer your questions. Mathgon, can you change the size of shapes? Caitlin, I don't think so. I tried to do that when Hebron and I were struggling to make them the same height. The only thing you can do is iterate it again to make it larger. So you can iterate, the parallelogram rhombus 4 times to make a larger rhombus.
Can you talk to me about math fluency? I'm teaching grade 4 this year, and about where my students should be in multiplication and division when it comes to math fluency by this time in the year. This is, again, my first time teaching grade 4, so I don't have a lot of familiarity with what expectations look like. So we have reviewed and practiced multiplication tables for up to no, that's not even true. I haven't really even done a ton of multiplication tables yet. Is that something my students should I have fluency in at this point of the year? I know we have a whole different aside about where, should we have the multiplication tables memorized or not? We got into a debate about that last year, but it actually is part of the curriculum now. So,
and it certainly wouldn't hurt. I would hesitate to say that your students should be anywhere at this point in the year, just because it's such a disrupted year. And, in some cases, students have gone from distance to face and back to distance and have different teachers and had time away from school. So I don't think there's a where you should be. I think it's valuable to have the students practice in meaningful ways, practice some of their times tables, whether that's through games, when you're talking about math or number talks, using visual representations. So some of the things like that Steve Wyborny has on his website for visuals that support multiplication and multiplicative thinking.
Yeah, I just discovered this Steve Wyborny stuff, and I was curious as to what your opinion of his stuff was, but you like it, eh?
Oh, I think it's great. And again, everything has its place and everything has a purpose. So you want to make sure you have a purpose for using them. So sometimes with sites like that, people are like, oh, they're so awesome, they're fun, and we're going to do them all the time. And they lose sight of, okay, what was our purpose in doing it and how is it improving student learning? But for sure, his tasks can suit those purposes if you've got them identified in the first place.
Mm-hmm.
Emily is saying, any ways to assess students who are not? No, I agree. You don't want to do worksheets all the time. So Emily, what we just did, where we hopped into that shared Google slide deck, it's pretty safe for students. You would need to have some class norms about not popping into other people's slides uninvited or messing with other people's slides. But I would say the class slide decks and the pair deck that we've been using are two of the best ways to get student data. The pair deck doesn't give you identifiable data. And so if you're looking to assess a specific student, it's maybe not ideal, but it gives you general assessment data to inform your instruction. The slide deck gives you more specific assessment data about each student. And what I like about the slide deck is it serves as not so much vertical. I guess if they're looking at a screen, it's vertical, but it's a non-permanent surface. And so students can work in it and other students can see it and they can pop in because they're not sure, and they can go in and and then they can go back and work on their own. And then you can pop in with little comments and have a conversation with junior students. Many, you can have that conversation through typing. Hebron, did you want to add anything?
Yeah, that's a great strategy. You could couple that with small grouping. I mean, breakouts are the saving grace of distance learning, essentially. So kids who are reluctant to mic on and video in a group of 2 or 3 students might maybe not turn on their video, but maybe mic on while they're working on a slide and ask you a question or respond to a prompt. So if you couple that, and then you have less variety. Like if you have the whole class in one slide, especially if you're on a Chromebook, we notice that it does lag and slow down a bit. But if you're breaking up your slides and have small groups where they have their own slide, but they're in a group and they can share, vice versa. Anyway, but that's a great way to do it. Slides and small groups.
Yeah, that's pretty much what I have been doing, except using Jamboard because I like them to be able to draw on it instead of slides. And they all have a different jam. But then I had to like have a whole like 20-minute conversation about like, we don't draw on other people's slides and blah, blah, blah. But then today I'm still on coding and geometry. Don't judge me. But anyways, so today we were doing the Cartesian plane and like connecting our knowledge of integers to like putting that on there. And so I wanted them to play like Cartesian plane Battleship. And like I had someone practice with me in the main Google Meet and we played together to show them. And then I put them in groups of 2. And like 4 kids were just sitting in their breakout room and didn't have anyone to play with. And I was like,
oh
my gosh. So then I'm like, I don't know if I should go to the point of like emailing parents. I'm just in this really weird vibe of like, these are kids that want to be in person. So I don't want to push them too much. But like, I don't know how to get them to feel comfortable to participate, even like with a partner.
Yeah. That's a tough. There's an element of fatigue. I know your class has gone from being in person to distanced. There is, I don't know if you noticed, and there's some of the teachers I've talked to, there is an element of fatigue that students go through at a certain point of doing distance learning. So it becomes difficult to engage them positively because they're
and also because they think, like we all do, we all keep waiting. When are we going back? So there's always in our mind that we're going to go back and I don't really need to adjust to this. I just want to wait till we get back face to face. And, hopefully tomorrow we're going to hear something that gives us a definitive date. And then it might be easier to engage your students and say, hey, we've only got this much more time to try this online stuff, to try this. And really it is a battle, and it's a battle that is at least North America wide. Because I've seen lots of different things, and all of the strategies you're trying are the same things that the experts are recommending. It just is a struggle. And it takes time, and everything takes longer online. And so because you've only been doing it, I know it feels like forever, but for a shorter time, and we don't know that end date, it just exacerbates the problem. Any other questions, comments? We really appreciate you taking the time out of your busy lives to spend yet more time online. But we do appreciate that you're coming out for these sessions, and we appreciate your feedback to help make them the best they can be to support you and your learning with your students.
Thank you.